Alright, let us show you the best stats presentation that you'll ever have in your entire life. So we had the mandate of finding the best time of the day to remember information by comparing our results to memory games played in the morning, afternoon and evening. During the 7 days, the 5 members of our team took the same memory test 4 times at each period of the day, so morning, afternoon and evening, in order to collect a total of 420 scores. The memory game we chose was called the sequence memory test, and it consisted of a sequence of buttons that lit up in a certain order, which we had to recreate from memory. Every time a level was achieved, we obtained a number representing our performance. The pattern got longer until a mistake was made, so the number was the level that we achieved. So basically, the higher the result we got, the better the score was, and the better we were able to retain the information at that time. Within the context of the study, the score was the variable x we wished to study. We observed a minimum score of 5 and a maximum score of 26. The other variable that was taken into consideration was the time of the day, so in the morning, in the afternoon, and during the night.
In order to analyze the data collected during the research, we used descriptive tools such as the average and the standard deviation. We found that in the morning there was an average score of 10.07 with a standard deviation of 2.38. In the afternoon, an average score of 10.19 with a standard deviation of 1.80. And in the evening, an average score of 10.12 and a standard deviation of 2.31. This suggests that the results were less constant in the morning and in the evening than in the afternoon, and that they were better in average in the afternoon. We also used the inference tool seen in class to analyze our data. We created 3 variables, mu1 being the mean results obtained on the test in the morning, mu2 in the afternoon, and mu3 in the evening. In conclusion, we would have needed to collect a much larger amount of data, and we would have needed to compare each member's score separately in order to have meaningful results. In our sample, we were only able to note a slight increase in scores in the afternoon, which is too small to apply to the whole population. Since we were not able to find strong enough evidence to reject H0, we cannot say that there is a correlation between the period of the day and our capacity to retain information.
Then we formulated our hypothesis. H0 meant that the average result of the memory test would be similar regardless of the period of the day, morning, afternoon, and evening. And H1 that the average will differ throughout the periods of the day. Using SAIL calculated the p-value, which gave us 88.49%. This shows that 88% of the time we'll be able to get results at least as extreme as the results actually observed under the assumption that the null hypothesis is correct. By comparing it with our predetermined significance level of 5%, we were able to determine by lack of evidence that we could not reject H0, meaning that we cannot reject the idea that our score from the memory game does not vary depending on the time of the day. Consequently, the result given by our inference tool shows that it is not possible to conclude a correlation between the time of the day and our capacity to retain information.
As for the possible bias, there are many factors that seem to have affected our conclusion. By looking at the tables below, we can see that each of our members' results are quite different. If we had considered each of our results separately, we would have come to significantly different conclusions. For example, some of us had a higher average score in the evening, while others were better in the afternoon. By combining all of our results in one table, they balanced out in a way. This may be good for a reason why our global conclusion was not strong. Another cause of our weak conclusion may be the fact that each team member has a different lifestyle and different cognitive skills. Some of us are more prone to working late at night, while others are really productive in the morning, and some of us are better at retaining information in the short run than others. We also had different schedules and personal obligations, such as work for example, that led to an uneven distribution of tests throughout the day. Finally, the test that was used highlighted a specific type of short-term visual memory, so it could be incorrect to generalize our results to all different types of memory: auditory, kinesthetic, short-term, long-term, explicit, implicit, etc. All of these factors put together certainly represent a high risk of altering the final conclusion.
The conclusion of our study, although disappointing, is plausible. In common terms, we did not find a link between our capacity to retain information and the time of the day. We could even say that we were far from finding a relation between those variables. The only interesting conclusion that stood out is the fact that the results obtained in the afternoon were slightly better and at a slightly lower standard deviation, which could be interpreted as follows: the closer we were to the extremities of the day, the lower and more volatile our results were. This is, however, not a valuable conclusion in statistical terms. Therefore, we will consider that this study did not provide enough evidence to prove this last theory. It is crucial to note that the conclusion we came to is not absolute. In fact, there are many factors that may have affected the results. First, we decided to collect 420 entries, a number that we found by approximating the standard deviation and by choosing ourselves the maximum error and the confidence level. We estimated that the standard deviation of our study would be 1.465. The observed standard deviation is around 2.16, higher than 1.65, meaning that we would have to collect more than 420 scores in order to have a truly valid study. Furthermore, we allowed a high maximum error of 10%, which may have led to a 10% error in the collected data. Finally, our 5% significance level represented a 5% chance of wrongfully rejecting the null hypothesis, or in other words, of coming to the conclusion that there's actually a relationship between the time of day and the memory capacity, while there is none.